Power to the truth. This is Margo. This is Thursday, February 7th, 2019, 4:14 p.m. Pacific Time, United States of America. So we've got another full show today. It seems like I always have a full show. We've got a new day's worth of methane data to look at. Yesterday, we had Monday, the 4th, as the new day, and now we have Tuesday, the 5th, as the new day. So I've uploaded it here for the Arctic view surface level, and we're looking at Copernicus atmosphere monitoring services. So got a little treat for you today. We're also going to be looking at Arctic sea ice, and the sun is going to be coming up in the next month and a half. By the end of March, the sun will be up, and it's starting to come up, and we will be able to start seeing the sea ice in the Arctic as it's coming up. So that's pretty exciting. So I already have this movie loaded for you on cams, and this is where we left off with the Monday data, where we saw this orangey release of methane coming out in the Atlantic Ocean and coming over towards Svalbard. We also saw a release, we saw it building off of from Norway and across here, and we're seeing a huge building in Russia here, and then we're still seeing a constant release in the Kara Sea to the east of Novaya Zemlya here, and we're seeing a release here in the Chukchi Sea. So let's let this movie run for you. It'll smooth out after the first time through. So we're seeing when it goes into the forecast period, the release comes out of Norway, and then the huge release comes up from Russia and just spreads out through the sea ice. There is sea ice there over here that it's coming up through, and you will see this. I'm going to show you the sea ice, and you'll get a whole different perspective on this. So it goes through Saturday for the forecast period. So I'm going to pause it there at the end of Tuesday. So here's where it was at the end of Tuesday. So it was still building here in Norway and building here in Russia and coming across here and just coming up and fading, coming up and fading in the Kara Sea. And then the release starts here, coming up from the Norway area, and then on Thursday the big release starts coming up in the Kara Sea. A wave. It just looks like a surface wave of methane being released. It's freaky looking, but that's what we're seeing. And our scale down here at the bottom, this dark brown, can be anywhere between 2160 to 10,000 parts per billion. This the red next to it is about 2140 parts per billion. This red is 2100. This orangey red, like here, that's 2100 parts per billion. The background color that we're seeing, this orangey color, is about 2060, between 2060 and 2080 parts per billion. So I'm going to pause that now, and I also have the movie loaded up for the global view, with Tuesday as the background again, surface level. So I want to show this, and we'll get a perspective on what's going on globally with all this methane and this huge buildup from Russia and how it's releasing. It's just incredible to me. Just flipping me out. And look at it here, releasing from, this is the Norway area, and here it is from Russia, and then here it is coming up in the ocean there. So, and we can see the background level for this whole European Russian area is pretty much in the orangey range, whereas over here in the North American region the background level is mostly in the green range. So that's pretty severe, I think. We can see methane releasing in the center part of South America, also in parts of Africa, parts of the United States and Canada, and where it's super cold, there's not as much methane releasing. So there's that. I will stop that movie for now. And now we're gonna print that and have this as a backdrop for the rest of the show. Now the next thing I want to show is sea ice from NASA Worldview, and this is what the Arctic looks like today. This is the circle, and this is a black area where they don't have data in yet. It comes in from satellite images from outer space. Here's the southern part of Greenland that we can see, and here's Novaya Zemlya. Part of that is in sunlight now, and so this circle is getting smaller now that the sun is starting to come up. This is where the sun is shining in the Arctic, but like for instance, here it was a couple of days ago, and we can see how much bigger the black circle was. So you can see day by day where it goes down. So if we zoom in, we can see some dirty clouds here. I don't know what to call them. That's what I'm calling them. We can see some sea ice here beside Greenland, and over here on the west side of Greenland we can't really see a lot because it's cloud covered. And then here's Canada, and here it's these Canadian, it's a northwestern areas of Canada, these island areas, and the sea, there is ice here. It's pretty much cloud covered right now, and here's the edge of this where the sea ice is, and here's Canada, here's Alaska, and here's Alaska coming around and coming around. This is the Bering Strait, and then this is Siberia over here. And then we can see it coming around, and this part of Siberia is still in the dark on the coast. Here's Novaya Zemlya, and we can see this little tippy edge of it is now in sunlight, and where we're seeing this methane releasing, I'll make that bigger, is specifically in this Kara Sea to, well, it depends on your perspective. It's to the east of Novaya Zemlya. So and there is sea ice there. I'm going to show you some. We can see it right here. Let's see if any of that is cloud covered. Where you see the colors, that means that it's measuring the sea ice temperature and that there's no clouds there. So this is cloud free. So this is the actual sea ice that we're seeing, and we can see that it's pretty broken up. Here's this inlet going in, and you see all these waves. You know what I'm gonna say? That's from beaming. The waves, it's from beaming. They're beaming everywhere. So here's what that sea ice looks like so far. See? You can see it all broken up there. It never came back really good here. It's very thin, and it's not very concentrated at all. So there's let's see. Oh, I thought that was something. And now what I'm going to show you, we're going to turn on. You have to go back a couple of days to get the sea ice here. It takes them a couple of days to get the sea ice on the model. And so here's the sea ice concentration, extent and concentration. And now we're going to turn on this blue marble layer. And so it's a little bit easier to see. So this is where we are with sea ice, extent and concentration as of February 5th, so 2 days ago. And so if we zoom in, we can see that the blue, where it's blue, it's a lot less concentrated and not as thick as where you have the white areas. And this circle here is the North Pole. So here's the Barents Sea. The Kara Sea is over here. This is Novaya Zemlya. So we're seeing the methane coming up here and here through this sea ice and in waves coming up. This is Svalbard. Now we're going to be talking a little bit about Svalbard today as a result of one of the comments that came in. But we can see that the sea ice didn't make it all around the island here. See the little blue pixels? That's just barely frozen there. And there's like no sea ice on this southern edge here. And not hardly any on the west side, and there's some on this east side. And remember, this is where the seed vault is. They've got it buried in a mountain on one of these, on Svalbard here. So the water is warm. It's just, and that's why there's no sea ice. And remember, we've talked about how the Atlantic is moving in and mixing with the Arctic Ocean, which is mainly freshwater, which is not salty. But when the Atlantic water comes in and mixes, it changes the salinity And so salt water freezes at a much lower temperature than fresh water, and so it has to get much colder where it's more mixed with the salt water in order for it to make the sea ice. So that's why we're not seeing hardly any sea ice in this whole region, because this mixing has come in. And it's warm. It's warmer coming in from the Atlantic. So, and it looks like Greenland has ice all the way down, and a little bit of ice around on the southwestern edge. Here's the Baffin Bay. It's pretty much ice covered. Not very concentrated at some places. And then over here at Alaska in this Bering Strait, it's not very concentrated. It is frozen a little, you know. It's probably not very good ice. And a little bit of frozen around. This is Kamchatka, Russia, coming down here. We see a lot of earthquakes. So if you think of the earthquake map, and this is the Aleutian Islands here, and we see earthquakes around here all the time. And then, of course, we see earthquakes coming up here and here, and coming down through the mid part of Alaska. So now that we've been looking at earthquakes, we can have a whole different appreciation, a newer appreciation for our geography and the sea ice and the methane and all that stuff. Because the more we learn about what's going on with our planet, the more we can understand all these systems that are interacting together. So I'm going to leave that for a minute. Now, I'm going to start with one comment. This comment from Heather McMillan came in under my video from yesterday, 5G methane and earthquake report. She goes, "Hi Margo, just wanted to let you know they identified hundreds of unusual vents called diatreme pipes all over Siberia that connected underground intrusions of magma to the atmosphere. It is my belief that the methane is coming from the magma underground. It is the magma releasing all that methane." Well, thank you for that, Heather. And if you have a link to that information, if you could just share it with us, that would be wonderful. And I did a little bit of research on my own, and here's what I found, and it's quite interesting. The first thing I found on Wikipedia, what is diatreme? And a diatreme, sometimes known as a Mare diatreme volcano, is a volcanic pipe formed by gaseous explosion. When magma rises up through a crack in the Earth's crust and makes contact with a shallow body of groundwater, rapid expansion of heated water vapor and volcanic gases can cause a series of explosions. A relatively shallow crater is left, known as a mare, and a rock-filled fracture, the actual diatreme, in the Earth's crust. Diatremes breach the Earth's surface and produce a steep, inverted cone shape. I think that's kind of what we were seeing when we looked at that that crater that had been formed by all that methane that had come up. And so when you have So if you have a place like Siberia, I'm just thinking, if you have a place like Siberia that has a lot of permafrost and it's moist from the snow, that snowed, and now it started melting and everything, and then you have magma come up and it comes in contact with all that water, and then you've got methane through the permafrost, you've got the magma. You know, some of that can be from magma and some of it can be from permafrost, and so I think that's very interesting, and I think you're onto something, Heather. I think you're definitely onto something, but you know, it would be interesting to find out if these crusty things form in Siberia where all that permafrost is melting and they're having explosions. Here's a view, an aerial view of Moses Rock diatreme from Cane Valley, Utah. Let's look at that. Now that's in a pretty dry area, I would say. That's just rock. So that's not from the permafrost. That's just from rock there. Here's another one. Diamond Head, a tuff cone that formed 200,000 years ago. Look at that. Oh my gosh. I wonder where that is. There's a city there. There's a dome. That's interesting. Hawaii is, oh, it's a crater on the Hawaiian island of Oahu. Interesting. So, these diatreme volcanoes are not uncommon, reported as the second most common type of volcanoes on continents and islands. Igneous intrusions cause the formation of a diatreme only in the specific setting where groundwater exists. This means most igneous intrusions do not produce diatremes. So they have to have groundwater in order for the physics to happen. So then I found this article. I did a little more digging, and I found this article from The Guardian back in 2017, August 1st. And this supports your theory, Heather. And it says, underground magma triggered Earth's worst mass extinction with greenhouse gases. There are parallels between today's and past greenhouse gas-driven climate changes, and I'm going to make this my feature article for today. And this is so interesting, and we're going to be able to relate this to a lot of different things as we see more things happen. And this is from Italy's Mount Etna, Europe's tallest and most active volcano, spews lava as it erupts on the southern island of Sicily, Italy, February 28, 2017. So, this story is by Howard Lee, and so here we go. Coincidence doesn't prove causality, as they say, but when the same two things happen together over and over again through the vast span of geological time, there must be a causal link. Of some 18 major and minor mass extinctions since the dawn of complex life, most happened at the same time as a rare epic volcanic phenomenon called a large igneous province, or an LIP, or LIP. Many of those extinctions were also accompanied by abrupt climate warming, expansion of ocean dead zones, and acidification like today. And remember, this was over a year ago. This was August 2017 that this was written, and we're seeing all of this. Earth's most severe mass extinction, the Great Dying, between 251.94 million years ago, began 251.94 million years ago at the end of the Permian period, with the loss of more than 90% of marine species. Precise rock dates published in 2014 and 2015 proved that the extinction coincided with the Siberian trap slip, an epic outpouring of lava and intrusions of underground magma covering an area of northern Asia the size of Europe. Now, I briefly showed one of those maps in one of my videos, but I don't remember when. But I remember this, the Siberian traps, and they think that that's where it's oil rich now. But those rock dates presented science with a new puzzle. Why was the mass extinction even much shorter than the eruptions? And why did the extinction happen some 300,000 years after the lava began to flow? Now, in a new study published in Nature Communications, Seth Burgess of the U.S. Geological Survey, along with James Muirhead of Syracuse University and Samuel Bowring of MIT, think they have the answer. As Burgess told me, it's clearly not the entirety of the lip that's guilty. There's a sub-interval that's doing the work, and I set out to figure out which sub-interval that was and what makes it special. Burgess noticed that the beginning of the mass extinction, as well as a jolt to the carbon cycle and abrupt climate warming, coincided exactly with a switch in the style of volcanic activity in the Siberian traps. During the initial 300,000 years of the eruptions, basalt lava poured over a vast area of Siberia, building to several kilometers thick. Can you imagine that? The lava just flowing and building. And this time there was some stress to life in the northern hemisphere, but no mass extinction. Life only began to disappear across the globe at exactly the same time that lava stopped erupting above ground and instead began to inject as sheets of magma underground. In Siberia, you've got the Tunguska Basin, which is a thick package of sediments that contain carbon-bearing rocks like limestone and coal. When you start intruding magma, it cooks those sediments and liberates the volatiles. So the deadly interval of magma in the entire large igneous province is the first material to intrude and pond into the shallow crust. In other words, it wasn't the lava, it was the underground magma that started the killing by releasing greenhouse gases. Norwegian scientist Henrik Svensson had earlier identified hundreds of unusual volcanic vents called diatreme pipes all over Siberia that connected underground intrusions of magma or sills to the atmosphere, showing signs of violent gas explosions. This new work emphasizes the importance of Svensson's 2009 conclusions. Now, I haven't clicked on this link yet. Let's look at this. So this is what Heather's talking about. Let's see where this goes. Oh, it's an article. Siberian gas venting in the end Permian environmental crisis. So people can go there if they want. So let's move on. This is interesting. The diatremes that have been mapped are... I hate those ads. I don't want that. The diatremes that have been mapped are the geologic representation of that gas escape on a catastrophic level. Our hypothesis is that the first sills to be intruded are the ones that really do the killing by large-scale gas escape, likely via their diatremes. And that may be what we're seeing. That really may be what we're seeing in this. That massive... See, it's massive here. And it's going to be more. Once this one warms up, there's going to be more. So, let's go back to our article. Svensson, who was not involved in Burgess's study, commented, "The Burgess et al. Paper is a crucial step towards a new understanding of the role of volcanism in driving extinctions. It's not the spectacular volcanic eruptions that we should pay attention to. It's their quiet relative, the subvolcanic network of intrusions that did the job. The new study shows convincingly that we're on the right track." Greenhouse gas as a killer. While other scientists have proposed that an array of killers may have been involved in the end Permian mass extinction, from mercury poisoning to ultraviolet rays and ozone collapse to acid rain, that sounds like things we've been talking about. Burgess argues that it was principally greenhouse gas emissions triggered by magma intrusions that caused the extinction through abrupt global warming and ocean acidification. I asked him to outline the evidence for that, and he says, "There are three primary lines of evidence that support that link. The first is, right before the onset of the mass extinction, we have evidence for a massive input of isotopically light carbon into the marine system." He went on to explain various lines of evidence that point to the source of the carbon being methane and carbon dioxide resulting from magma intruding and cooking organic-rich sediments, and he continued, "Just prior to extinction and persisting after the mass extinction, the sea surface temperature is thought to have gone up about 10 degrees Celsius. You get that increase by pumping greenhouse gas into the atmosphere, so that's the second. And then the third line of evidence is of physiologic selectivity to the marine mass extinction. Organisms that make their shells out of calcium carbonate suffer much higher mortality than organisms that make their shells out of silica, for example, which suggests that the ocean was acidified, and you get that by pumping gases like CO2 into the atmosphere. And you know, we talked about this. Someone talked about the crustaceans not being able to make their shells because the ocean was too acidic. I remember a comment like that. That's not to say that other factors had no role in ruining the environment. There is a cacophony of kill mechanisms. And I think that this first pulse of sills is the trigger for quite a few of those sitting at the top, and beneath it are a cascade of negative effects from ocean acidification to climate warming and on down the line. A series of associated events. Coincidentally, Joshua Davies of the University of Geneva and colleagues have just narrowed down the trigger for the end Triassic mass extinction, another of Earth's biggest mass extinctions, to the underground phase of its associated large igneous province. The Central Atlantic Magmatic Province, or CAMP, is another enormous igneous province which stretches from Maine to South America and includes the Palisades Sill visible from Manhattan. They too used high-precision rock dates on a vast sill that intruded organic-rich sediments in the Amazon basin and found that this underground magma intrusion also coincided with the extinction. Like Burgess, Davies also argues that greenhouse gas baked from sediments drove climate change, which drove the mass extinction in a smaller repeat of the end Permian events, this time 201.5 million years ago. I think camp is very similar to the Siberian traps, and that's the reason why there's an extinction at that time. I'm not surprised that they got similar results, said Burgess. Diatreme pipes from magma intrusions have also been identified as a likely cause for a more recent global warming and very minor extinction event, the Paleocene-Eocene thermal maximum, or the PETM, 56 million years ago. Again, prodigious quantities of greenhouse gases erupt from oil-rich deposits, although in that case it's been hard to locate and date the smoking gun intrusions due to the fact that they are under the Atlantic Ocean. A predictive model. Burgess's insight makes a testable prediction. Only large igneous provinces characterized by sills intruded into a volatile, fertile basin are going to be lethal on a global scale. This may explain why some LIPs are tied to mass extinctions and some are not. Burgess thinks that the Deccan LIP, which happened at the time when the dinosaurs disappeared at the end of the Cretaceous, would not have triggered a major mass extinction on its own. The Deccan traps doesn't satisfy those two criteria. It's predominantly flood basalt lavas erupted onto old granitic rock. Acting alone, there would likely have been negative effects on the biosphere because of the gases and the particulate matter released by those lavas, which are not significant, but I would argue that acting alone, it would have been minor relative to the observed mass extinction, but with the Chicxulub impactor sharing the causal burden together, they caused the mass extinction at the end of the Cretaceous. Parallels today. The more science learns of these past greenhouse gas-driven events, the more uncomfortable the parallels to today become. I asked Burgess if it was ridiculous to make the comparison. No, I don't think the comparison is ridiculous at all, and I think that the time scales over which the environment changes associated with mass extinctions are frighteningly similar to the time scales over which our current climate is changing. The cause might be different, but the hallmarks are similar. Geologically fast buildup of greenhouse gas linked to warming, rising sea levels, widespread oxygen-starved ocean dead zones, and ocean acidification are fairly consistent across the mass extinction events, and those same symptoms are happening today as a result of human-driven climate change. Even though the duration of those past events was longer and the volume of emissions was larger than we will produce, we are emitting greenhouse gases around 10 times faster than the most recent mildest example, the PETM. The rapidity of today's emissions prompted scientists Richard Zeeby and James Zakos to observe in a 2013 paper, Anthropocene will more likely resemble the end Permian and end Cretaceous disasters rather than the PETM, meaning it's going to be a lot worse than that. So we're almost done here. When the promises made for the 2016 Paris Agreement on climate change are added up, they aim to limit peak warming this century to about 3.3 degrees Celsius compared to about 4.2 degrees Celsius for the business as usual scenario, and the 2 degrees Celsius limit the world is aiming to stay under. It's sobering to compare those numbers to the majority of mass extinctions in the geological record, which were characterized by abrupt warmings typically around 6 to 7 degrees Celsius. So, I'm going to bookmark that. That was an excellent article. I will leave the link below. And I think this is one of the pieces of the puzzle of what's going on, and I think we're going to be seeing more and more of this magma coming up to the surface, and as it comes into contact with the water, that's where it's causing problems. So thank you, Heather, for bringing that to our attention. And like I said, if you have a link that you'd like to share, Heather, or anybody else concerning the diatreme pipes, let's see them. I had not heard of them before now. I think it's fascinating. And then my other news article is from Seymour Rock's blog post from Thursday, February 7th. And he actually posted this yesterday. They're a day ahead over there. And this is my friend Robin Westenra in New Zealand. And these are articles about the Nelson fire. This Nelson is located in the northern part of the southern island of New Zealand. And there's a huge fire. I reported on it a couple of days ago, and it's a state of emergency, and the conditions have worsened, and they're evacuating people, and it's a whole thing. So look at the smoke there. I'm not going to play this because I don't want to get a YouTube strike. It says fire crews have been working continuously to try and contain the large fire in Nelson that broke out on Tuesday afternoon. Nelson Council said evacuations are now underway in the west side of Teapot Valley, affecting about 25 properties. The council said the evacuations were a precautionary measure because of the increased fire intensity seen this afternoon. More than 200 properties have been evacuated overall, affecting about 400 residents. One home has been lost and several others damaged by the fire's intense heat. And cordons remain in place at a number of locations. And then they go through road closures and what to do and this and that, where to go, and things like that. Fire roaring away in Teapot Valley, and here's their centers that they can go to at St. John's Church, Wakefield, and different places. And they're having to evacuate their livestock and take them so that they're not in danger. And here's another Prime Minister says the emergency response is well coordinated and said they've got the resources to help deal with it. So anyway, it says where the number of days are very high and extreme forest fire danger could increase to more like 12 to 13 days per year on average, and maybe 20 to 25 days in the worst years with climate change. So they're talking, it's climate change. So it's sad, and we need to pray for the people there, but this is what's going on, and it's going to become more and more. We're going to see more and more incidents like this as the climate heats up. So thank you, Seymour Rocks, for that reporting from down under. Now, let's go right to our comments. I'll try to cover all the ones that came in. Robert Forsyth left a couple more comments. This was under my Arctic sea ice, melting permafrost, methane, and earthquake report from January 17th. He says, Margo, thank you for your kindness. You're welcome, Robert. I've also seen methane reports from other sites. I've seen video from BBC on site in Siberia, horrible bubbling, and now understand the coming bloom. What we see now is nothing of what is to come. There is still methane production from man-made sources that is the same or more than natural sources. However, they will come nowhere near what is coming very soon. I agree, Robert. It's going to be bad. And then he leaves another comment saying, lakes are forming over Siberia. They are dark and release larger and larger quantities of methane as time goes by. Some of the largest lakes keep releasing even in winter. Yeah, I've seen that. I've seen reports where the lakes are releasing in winter, and the ground is just not freezing, and it's awful. Thank you, Robert, for being here and sharing that with us. And then under my video from yesterday about 5G, methane, and earthquakes, I left a comment and pinned it to the top, and these are more videos that I've done regarding 5G and satellite dangers and microwave, and a picture of a harp ring that I took. This one, earthquake report with Margo from January 6th, I show a picture of a harp ring. I took the picture in the sky, and it's a harp ring, and what it looks like and how it spreads out and stuff. And and then 50 years after, how to wreck the environment, and then part 1 of this paper, how to wreck the environment, and so forth, if you want to learn more about all of that. And then Valhalla says, sounds good. So, and then Valhalla agrees. He says, I agree with what you said about 5G, Margo. Yeah, thank you, Valhalla. Thank you for that confirmation. And it's not a pretty sight. Doogie Dog says, hey, Margo. Yeah, you sound sad tonight. I was very sad. I'm better today, but I was very sad. Reporting on 5G just breaks my heart. But anyway, but I certainly relate. Boy, do I relate. Well, it is sad, nothing but sad. I think there are armies of us now just asking God to intervene, and this is what I pray. I no longer ask Him to fix things, I ask Him to come back. I agree. There's no fixing it. And why would God fix what when people, the satanic system. Why would God fix this satanic system unless people are going to turn away from what they're doing, and unless Satan can get kicked out? You know, it's not going to happen, in my opinion. And continuing, well, just like it says, the whole creation groans and travails. Look at all the friends you're making that you will know in the new world. That's a very, very beautiful thought. Thank you, Doogie Dog. And I am making a lot of friends, and I appreciate every one of you here. Nothing is going to change. It is futile. All we can do is we grow spiritually. Right, I agree. Bless your heart. Pray for you daily. If you ever need anything, please let us know, please. What a beautiful comment. Thank you, Doogie Dog. Thank you. And I will let y'all know if I need anything. But right now, I'm holding. Everything's holding. So, thank you. And thanks for being here and holding the light with us. And then here's Heather's comment that I already read. And thank you for that, Heather. Thank you for being here. Then Tom Bell had a rant. He left 3 comments. So let's read Tom Bell's rants. He says, it's a madness. Yes, it is a madness. And then his next comment, he's ranting. He says, I just flew back from Cyprus to the UK, a 4.5-hour flight. Oh, and Tom Bell lives in Wales. He's our friend from Wales. 4.5-hour flight. And my observations from 36,000 feet indicated total weather manipulation and geoengineering. Thousands of miles of electromagnetic field lines in the clouds, aircraft trails everywhere. Observed them being turned on and off. Air quality due to aircraft pollution was disturbing, like flying over brown fog. And when I checked NASA Worldview for yesterday over the UK and Scandinavia, and anyone taking the time will be shocked at the deliberate aircraft pollution, aka geoengineering, that's been carried out. It's a madness. I don't believe I can do anything to stop everything that's going on anymore. Most people I've tried to reach think I'm nuts. Those in power and those in positions who could stop these things are all bought and paid for and have sold their souls to the devil. So I've got my spiritual house in order and understand clearly how the end times play out. Only a spiritual intervention will stop the madness, so I try and keep my eye on what's going on, but try and have some fun, which isn't easy once you've taken the red pill, and very much appreciate the work of your good self. Thank you, Tom, for that report, and I totally agree. And we're going to look at NASA Worldview in a second and see what you're talking about. And then he leaves another message. Sorry, Margo, I just wanted to point out one more thing. I've just checked the temperatures according to Null School Net satellite data for the days I recently spent in Cyprus, and the temperatures they showed at the surface and just above surface for my time there, and they aren't even close. We recorded temperatures from 20 to 25 Celsius, and the sun's radiant heat was stinging, yet the recorded satellite temperatures were from 12 to 14 Celsius. They were out by a massive margin, so once again we see data being faked. It only cooled down on the last day when a geoengineered storm was deployed out of Africa with its right-angled weather pattern formations, which I documented. I'm living in a madhouse run by idiotic lunatics and scientists and meteorologists that are derelict off-duty. I don't know how they can look themselves in the mirror and feel proud of themselves. Sorry for my rant. I hear you, Tom Bell. I hear you. Well, thank you for that report on that temperature discrepancy. You know, it's just hard to know. It's hard to know. It's like you got to be there and figure it out yourself. So let's hop over to NASA Worldview. This report is going to go way long, I can already tell. But we're turning off blue marble, and we're going to turn off the sea ice. And then we're going to go to geographic. Now here's NASA Worldview from today. And now I know he was talking about a day or two ago, but here's Italy. Cyprus is over here, okay? Cyprus, where are you? Right here is this little island in the Mediterranean is Cyprus. So he flew from Cyprus to the UK, and he was 30,000 feet in the air. And when you start coming over, look at what we're seeing. Look at all of this beaming. See those lines? That's evidence of beaming in the clouds. All of these, and see how they're going different directions? That's beaming. It's hatch marks. Here's the Netherlands. And you can see this whole area down here. That's all manipulated. Here's more going sideways. And this is from today. And I've noticed that a lot of times these areas, Norway and these areas up here, do get heavily beamed. The UK is heavily beamed. Look at this. Look at these ripples. This is the UK here. You see, it's just heavily beamed. I don't know exactly what's causing it, what kind of ionospheric heaters or what, but that's not natural. It's just not. And so you can see the spraying. Here's some of the spraying, like what he's talking about. But it's mixed in with the clouds here, so it's kind of hard to tell. Then if you go back a day, you can look for yourself and see. But you just go to NASA Worldview and look around and see. Here's some of these dirty clouds. I think these are some. See, it's brown, and you can see spraying through there. I don't know how much of what's clouds and what's spraying. You know, it's just hard to tell. Now here's ripples. See the ripples up here. See that? That's from beaming. And that too. So it's a shame. It breaks my heart. And see this whole dirty cloud here going across from Norway all the way over to Iceland. I showed that from the Arctic view. So there you have it. So now let's go back to our comments. Uh-oh, I didn't mean to do that. Thank you, Tom, for being here and holding the light with us. We love you. Sensible Hair says, got this a bit late as I'm visiting a near-term human extinction support group friend across the border in Spain. As ever, thank you, Margo. Thank you, Sensible Hair. And thank you for reporting from Spain. I didn't realize you were in Spain. And then Random Variable checks in, says, hello, Margo. Hello, Random Variable. Great upload as always. Got a question for you. I was clicking around on Null School and looking at the ocean surface temperature, and then he gives the coordinates. It seems Svalbard set up a hot tub off its coast. Any idea what the heat anomaly is? Seems to have formed in the last couple of years or so. Thanks, RV. Well, I think it could have to do with the underground volcanic activity, because they did talk about it happening in the Atlantic Ocean, and there is a volcanic ridge that goes in the ocean. And I know that Iceland has volcanoes on it, and so I'm thinking it could be that. And it could be, magma coming up. I mean, those are my thoughts right off the bat on that. So that's all I had to say on the comments. So now I'm going to close those tabs out. And let's get to our earthquake report. So I decided to do the earthquake report in a separate video. So I will close out this show for today and saying I do believe time is short and that we are in the end times, and I recommend everyone get your spiritual houses in order. And until next time, go in peace, God bless, and goodbye.